Hello all my JavaScript friends, this is TheVirtuoid, aka Mike Smith, and this is video number 2 of our cut class series. Now in video number 1, we took a look at the cut base class and the square class that allowed us to be able to physically cut a piece out of the puzzle. This video we're going to be looking at the big one. This is the Jigsaw Puzzle. This is the one that's going to be able to produce these beautiful jigsaw puzzles that you currently see on the screen here. Isn't that lovely? It took me forever to get this thing figured out. But hey, that's what we're all here for. We're all here to learn, and that's the whole purpose of this. So let's get into it. Just a very quick reminder, as before, we have this cut base. And this cut base is used to be able to supply basic properties and basic methods to each of our different cuts. And a cut class is defined as a class that physically is used in conjunction with the UI to cut a piece. And again, we have image, width, and height. No big deal there. But the two biggies are our cut and configure puzzle cut, excuse me. Both of these methods are used by the UI. Let's go over to the UI here. Both of these are used by the UI to be able to configure our pieces, or to prepare them to be able to be cut, and then to actually physically cut the piece itself. So it's very important that if you're going to be doing your own jigsaw puzzles, that you extend the cut base. And sure enough, that's what we've done with Jigsaw. So let's take a look at it. Again, we just have the constructor as we normally always have. We got the tab size. We've got cut there. You want to see something cute? This is where you really want to do some refactoring once you get everything working. I'm going to hover over that. Function cut is overly long and function cut is overly complex. Yeah, babe, it is. So, hey, if you really want to get into some good refactoring, now this will be a great one to be able to do. But anyway, so we've got cut, and it's very, very simple, except that the pieces within the jigsaw have certain characteristics. Like for instance, let's take a look at the picture again. A jigsaw piece can have one of 3 different sides. It can either have a straight edge side. It can have what I call an any side, I-N-N-Y, which will basically be the slot, for lack of a better term. And it can also have an outie side, and that's basically the tab, and I've got those circled here. That will allow us to be able to define or to tell our systems whether we want to be able to cut a slot out, or to insert, or to cut it out to where we're showing a particular piece, and then make adjustments to the piece accordingly. So once we're back to the code here. As you can tell here, this is where I've got the the 3 different types of edges we can have. We can have just a regular old edge, or we can have an any tab or an outie tab. Not a big deal there. So let's take a look at the most important things. It's going to be the cut and the configure. So what we're going to do is let's get down to the puzzle cut first. Again, puzzle cut is what allows us to be able to configure our pieces so that when the cut command occurs, or the cut method is called by the UI, it knows what to do with itself. And all of that is based upon, let me make sure all this is in the screen. All that is based upon this information here for each individual piece. Now, basically what it is that north, south, east, and west will define what type of edges. And again, those edges are defined way up here in lines 19, 20, and 21. It's either going to have an edge, a straight edge, it's going to have a tab, or it's going to have a slot. So let's get back down to the code. That's what the north, south, east, and west is all about. The width and the height are the width and the height adjusted for the tab. Because obviously, the width and the height is basically, you can think of it is that if it does have a tab, I don't want the full width to be the image plus the tab, or else I just never get a tab. The width is actually going to be the width of the puzzle piece minus any kind of tab. And that's going to become a little bit more obvious once we go into the code a little bit more here. Again, starting X and starting Y is where I'm going to start the cutting process, or tell the cut method to exactly what point physically within the image that I want to start the cutting. And this is going to get adjusted based upon whether I have a tab or not. Because for instance, if I have a straight edge, it's going to start at 0, 0. Let's just assume we're at the, in the upper left-hand corner of the image. But if I have a tab on the north-hand side, then the Y part is going to actually be down from 0. It's going to be whatever the height of the tab happens to be. The checking point is a point that's in the middle of the table that allows us to be able to compare checking points for each piece to know whether they're going to be connected or not. So this is going to always be smack dab in the middle of the piece, no matter how it's cut on the outside. X adjust and Y adjust, again, are just some simple adjustments that are made within the piece to be able to get everything to line up correctly. And of course, we push all of that as we go along. Whoop, there we go. Got it up on the screen now. All right. So here we go. Here's the big thing. For row and column, what are we going to do? Well, the idea here now is that we've got to be able to figure out what's going to be an edge, what's going to be a tab, and what's going to be a slot. So the edges are going to, the edge on the north or the edge on the east or the edge on the south or the edge on the west are going to be dependent upon whether we're on row 0 or column 0 or the maximum row or the maximum column. So that's one of the first things that I do within this entire section right here is I want to be able to say, okay, if I'm on row 0, then I know that my northern edge is always going to be a straight edge. If I'm on the very last row, my southern edge is going to be an edge, or my southern part of the puzzle is going to be on edge. If the column is 0, then the west is going to be an edge, and if the column is the largest possible column, then the east side is always going to be the edge. At that point now, I have to figure out whether I'm going to have a slot or I'm going to have a tab, and that's what all of this little piece of information right here occurs. So if I have a null piece on the south, then what I want to do here is I want to first of all randomize whether I'm going to have an any tab or an outie tab. And if I have an outie tab, then I know that the north edge of the piece in the next row is going to have an any tab. So if I have an outie, actually, let me back up there a little bit. If I end up with an any tab in the south, then I know that the north edge of the next row, and there's the next row right there, if my south is an any tab, I know I'm going to have an outie tab. Otherwise, if it's an outie tab, I know I'm going to have an any tab. And you're not seeing that on the screen, are you? Let me expand that out slightly here. Da-da-dum. There we go. So now you can see it a little bit better here. So if my south piece is an any tab, north piece of the next row over is going to be an outie tab. And if it happens to be, if it's not an any tab, then my north is going to be an any tab itself. Same thing here with the east side. And let me expand this out here so you can see it a little bit better. Same thing with the east side here. I'm going to randomize an any tab or an outie tab, and if my east side happens to be an any tab, then my west side in the next column over is going to be an outie. And if my east side does not be an any tab, then my west side is going to be an any. And that's actually the reason why we only check for south and east. I'm not checking for north and I'm not checking for west because those would have already been set by the previous row. So for example, let's just say on row 0, column 0, my south side ended up being an any tab. Well, that means that row 1, the north side of row 1, column 0, is going to be an outie tab. When I finally get around in my for next loop here to be able to get to the row 1, I already have the north side set. So all I ever have to check for is the south side and the east side, because automatically the south side, the north side and the west side will be set. At this point then, it's just basically making sure I've got my piece width and height is set correctly. And this is where I said that the piece width and height are actually the width and the height of the piece that does not include any type of outie tab. So that's what this is taken into account here. If I've got an outie tab on the width itself, the width itself is the width, is the original width. So we go back up top here. Yeah, the width and the height is first set up here at piece width and piece height. This is just the normal piece width and piece height. Then I'm going to add or subtract based upon whether I've got outie tabs for the width, outie tabs on the east and west, and for the height, outie tabs on the north and south. Then finally, I'm going to set the starting X and starting Y locations. Again, that's going to be where the physical cut starts. So it begins at 0, 0. If I have a tab on the north, then I've got to move that Y south by a tab, or if I've got an outie on the west, then I've got to move the X out by a then I got to move the X out by a particular size, and that's where that's where this little section comes in here for both the piece starting X and piece starting Y. The checking points are going to be real simple. I pop that into the middle there. And finally, this Y adjustment and X adjustment allows me to do an adjustment onto the piece when the cutting is finally done to make sure everything lines up all nice and pretty. And then I finally just return the piece edges. So piece edges in this case is all of our pieces in a two-dimensional array, so I can very easily access it by ordinal numbers. And that's all there is to this particular thing here. Alrighty, now we've got to actually cut it out. And that's going to be a doozy of a one. So here's the cut. Again, as you can tell, a cut is overly long and overly complex. But the real basic idea here between the cut is I'm going to have to grab that particular piece, no matter what I do. And once I grab that piece, once I grab the particular piece, I'm going to then figure out what needs to be done with it. In fact, let me just throw this here so you can see it. There we go. So how do I do that? Well, I grab my north, south, east, west, width, height, starting X and starting Y from my piece edges. So now I have the piece and I can start working with it. Because the idea here is I've got to look at each one of these different edges and determine or tell the system how to cut out the edge. That's what a lot of this does here. Here's the begin path. In the square, it was just, hey, cut from here to here. It's no big deal. But this one, I got to do paths. And this begin path allows me to be able to tell the context saying, okay, this is where I want to begin your path cutting. All righty, we're going to move to X and Y. This is going to move the cutting piece. And then we begin the fun stuff. We're going to switch in north. What happens if we have an any tab? What happens if we have an outie tab? And what happens if we have an edge tab? What I have done here to make it a lot easier on myself, because again, as you can tell here, cut was here we go. Cut was overly long and overly complex. What I have done here is that each one of these particular functions here, whether it's an any north, an outie north, an edge north, or in this case an any east, an outie east, or an edge east, each one has their own little routine. And that is over here on Jigsaw Cuts. You can see, let me just throw that over here. There we go. Edge east, edge north, edge south, edge west, any east, any north, any south, any west, outie east, outie north, outie south, outie west. So what happens is that let's just take east. Well, since we're here right now, let's just take east any tab, and let's take a look at what any east does, because all these pretty much does the exact same thing, with the exception of edge. It's a little bit different. So we call this .any east. We go all the way down the bottom. And any east, there it is right there, any east returns any east args. So then I pass it to any east. Let's take a look what any east does. So any east basically says, okay, I am now starting, my XY is going to be on the east, actually the northeast corner of the board. Where do I want to go from here? Now this is an any or a slot. So what we have to do here, and what's really nice here, is we first of all go to, we've passed the CTX. There we go right there. We've passed the CTX over through args. And what we're doing here, and this is what finally worked for me, is we're using this Bezier curve 2 function. And this allows me to define two control points. And I'm not going to go through what a Bezier curve here is. You can find them all over the place on Wikipedia. But if you want to take a look at the context, you can always take a look to see what a Bezier curve does. And it just allows me to draw these really nice, funky looking curves. So I've played around with it until I found what the best control points are for the curve. So this is basically control point number 1, control point number 2, and the final ending point of the piece. So it starts at its current XY position, uses the control points to figure out how to curve itself, and it ends up at the, in this particular case, the tab half size section. This draws, if you can, and I'll put a picture up here on the screen, but this draws a, this draws the, since it's the east side, this draws the upper part of the any section. The second Bezier curve, let me get it up on the screen here. The second part of the Bezier curve draws the little cap, and this third part draws the other half. And then I do another line 2 to get to the, in this case, get to the southeast corner of the puzzle piece, and then I return my X and Y. And that's it. All of our any pieces follows the exact same format. Any north, any south, any west. It's the exact same format. A line 2, 3 Bezier curves. We'll go back to any east. A line 2, 3 Bezier curves, and another line 2. That's all it is. And these Bezier curves either goes inwards, which is the any tab, or as they will for the outies. I've pulled up outie east here. As it does for the outies, it goes outside. But it's the same function. Line 2, Bezier curve number 1, Bezier curve number 2, and Bezier curve number 3, which will draw the first third or the top part of the tab or the slot. The cap to the tab or the slot is the second one. The third one is the other edge. And that gives us that nice, pretty looking tab or slot that we see on the Jigsaw puzzles. So what do the edges look like? Well, they're incredibly simple because they're just exactly the same as we had with the square. All we're going to do here is we're just going to do a line 2, and just that's it. We're just going to do a line 2 because it's an edge. There's nothing else really to it. So that's the whole key here for the Jigsaw. I have taken each one of the possibilities, edge east, edge north, edge south, edge west, all of that, to be able to define exactly how the cutting tool is going to work with the Bezier cuff. I'm sorry, how the tool is going to work, whether it's an edge, whether it's an any tab, or whether it's an outie tab. And all in all that does, let me just clear off some of the screens here so we can see what the heck is going on. Let's just close tabs to the right. So what happens once we finish it all up? What does happen? Well, let's take a look. So once we go back to the cut, we just go through real quick what happens here. Again, we did that begin path. We did the first move to. Then we did the north side. So the move to is, you can picture, if you picture kind of a square, the move to is now in the upper left-hand corner or the northwest corner. So now we do the north side. That moves the XY over to the northeast corner. Then we do the east side. And that will get that will move our XY eventually down to the southeast corner. Then we do our south side. That will move our XY over to the southwest corner, and finally we do the west side, and that will move it back up to the northeast corner. And if everything is working perfectly fine, cross fingers, those 2 points will meet with each other, because once they meet with each other, we say we're closing it out, and then we're going to clip it. That's the most important thing. When we do the clip, that basically says, okay, everything within that clip, because we've kind of made it a square now, everything within that clip is going to be included with the image. Everything outside is not going to be included with the image. It's going to be transparent. And in that case, it's just a simple matter of drawing the image. And just as a reminder, there's a whole bunch of different parameters here. This is the actual image itself. This is our starting X and starting Y parameter that we referenced to earlier. This is where we're going to start the drawing itself. This is the width and the height, which is going to be larger or smaller based upon whether we have tabs or not. And this is the destination, 0, 0, width and height. That's it. And we're going to draw it into that image. We're going to put it inside of a span. We're going to append it, and we're going to return that piece like a champ. And just like I said before, all we have to do then is have UI to come in and say, oh, I've cut the piece. Let me bring that up on the screen. I've cut that piece. I'm going to set the dimension to that piece, and then I'm going to do my own very way. And when we finally are all done, we have all of these wonderful looking pieces. So you can see that the real important thing with the jigsaw, or this jigsaw, is figuring out how to draw that inner, using the Bezier curves to draw the inner or the slot and to draw the tab, what I call the innie tab and the outie tab. Mine's is very simple and very basic. You can use anything within each one of these different, let me bring it up here. You can use anything you want within this, all of these particular routines to be able to draw any kind of fancy patterns you want. Now, for instance, mine are all exactly the same. Technically, if this was a real cutout piece of on a real jigsaw, these all pieces will all intermix with each other. Luckily, we don't have to worry about that. But in reality, what I should do here is have a little bit of fudge factor, so that no two tabs and no two slots are exactly the same, and that'll give the illusion that it should not fit together. So that's that's something that we can do with these innie with all of these different routines, the edge east, the edge north, edge southwest, the innies, and all the outies. We can draw anything we want to, but it all doesn't really matter, because all we do is do those checking points, and once those checking points are set correctly and it checks based upon the points, I don't care what it looks like. And that's the beauty of this thing. If you want to really make some fancy edges, go right ahead. It doesn't matter to me. It's not going to matter in a computer program. You can do whatever you want, and it will figure it all out for you automatically. But that's all there really is to the Jigsaw Puzzle cut. I know this was a little bit long and a little bit involved, but I tell you, once I figured out how this thing works, first of all, it ended up being working very simple, but second of all, the possibilities it could actually open up. So that will complete the Jigsaw video. Hope you enjoyed it. Hey, make sure you hit like and hit subscribe, which I'll tell you about here again. Thanks for watching. Subscribe to this channel to view more videos. Click on the like button on this video and visit us at TheVirtuoid.com. Also, support us on Patreon, where you can get access to member-only videos. Links are down below. Again, thank you very much for watching, and keep on coding.